This is Notes4Engineers. I'm Alistair Cook, and I'm very pleased to be joined today by my good friend Michael Webster.
Hey, Alistair.
Hey, good to see you here.
Good to see you too.
So Michael is with the, what part of Nutanix are you with?
I'm in the global R&D team,
Excellent.
so the engineering team.
And the people who can live anywhere and still do a really good tech job, because of course Michael, like myself, lives in New Zealand. Lovely place to live, just not very much tech is invented here.
That's right, yeah. So it's really fortunate to be part of a global company out of Silicon Valley and be able to work from home in New Zealand.
Cool. And Michael, many of you will know, comes from a lot of time with VMware, and prior to that with customers who implemented Oracle on top of VMware solutions. So that's been one of his focus areas with Nutanix, is looking at best practices for putting large things on the Nutanix platforms, and that's what you're going to have a little chat with us about today.
Yeah, that's right. So I'm one of the VCDXs that at Nutanix we're fortunate to have quite a number. I think we're up to 7 or 8 now.
Keep hiring more.
We keep hiring more. So people ask, why does it take so many VCDXs to work at Nutanix? I say, well, to make things really simple, you've got to understand them really well.
So this is the advanced simplicity thing.
Yeah, that's right. And I'll tell you what, Oracle RAC is very complicated, and it's very hard to get right. And if you can simplify the infrastructure that lives underneath it and make it work properly and make it easier to manage, then that's going to be better for a lot of customers, because there are a lot of traditional problems that occur in Oracle RAC environments in particular. Now, my role at Nutanix is a solutions and performance engineer. So that basically means that I've got to try and build things and then break them and then tear them down and build them back up again. And what I've been working on for the last few months is Oracle RAC with Monster virtual machines on the Nutanix platform and doing vMotion while it's under high load and transactions are rolling through the platform at the same time.
So that's that whole collection of things is more than we're going to cover in 10 minutes. So what are we going to focus on?
So what we're going to focus on is the actual vMotion process and how Oracle RAC was set up and how the platform works in its simplest form.
Cool.
So we'll start with some hosts. So Nutanix is a converged platform. You've got storage and compute in the same boxes. You've got a little 2U box. So I'll draw my little 2U box here. And inside this 2U box, you've got 4 compute nodes and storage nodes. And my diagram's not very great, but that's the back of the box. If you draw another box, which is the front, you've got 24 disks in the front of that box. Each node has access to local flash storage for high performance and also hard disks for capacity. So when we're talking about a big database, we want to make sure that the data files that are going to be accessed the most live inside of the flash tier or the SSDs, and that's completely automatic, so I don't need to worry about that. Now, in terms of the way I'd set up my Oracle RAC environment, I had 3 vSphere hosts running Oracle RAC, and I had 1 host which was the test harness, and that was basically communicating with all these other hosts. Now, the way that we connect these together is just simple Ethernet. So there's no fiber channel to worry about. We don't have to worry about any LUNs.
It's all converged network, and
it's all completely converged. 10 gig Ethernet in particular, especially when you're doing multi-NIC vMotion, which is what I was doing. So each of these boxes has completely independent dual 10 gig NICs. Network ports.
For disclosure, I teach the Nutanix training courses, and one of the key things is that this thing that Michael's drawn as a blade enclosure at the top is really just 4 discrete servers that share power and management. There's no I/O plane sharing.
Yep. Now, one of the other important things is we have a storage controller on each node, which means if you scale out the number of nodes, you scale out the number of controllers, you scale out the performance. So we're not bottlenecked by having a single controller for everything, or even having a few controllers for everything. As you scale, you add more performance, which is great for Oracle RAC, because Oracle RAC itself is a scale-out database platform. So we have all of our little controller virtual machines on each of these nodes, and that serves up a local NFS data store to the hypervisor. Now, the disks that are associated with this controller virtual machine, they're not RDMs, they're not VMDKs, it's a direct pass-through to the controller of those disks. So we're basically bypassing the hypervisor straight to those disks to get the best possible performance, but also so that we can run the native drivers that the controller manufacturer produces for that particular controller. And then we've got total control of the entire package. So if we look at our Oracle virtual machines, what I did is I started off each of these Oracle VMs, and I'm purposefully making these bigger, on a single node. And each of these virtual machines was 8 CPUs, or 8 virtual CPUs, and 112 gigs of memory, and it had about 6 terabytes of storage assigned to the database, and about 600 gigs was active. So that was the part that I was hammering constantly during these tests. I was using a tool called Benchmark Factory for databases, and it was a TPCC type simulation.
But a fairly large working set of hot data. It's not like an artificially small set of hot data to make things look good.
Absolutely. So I purposefully filled this entire system up to 75% full, because then I'm guaranteed that not all of the data is going to be just in the SSD tier. I'm going to get a good performance across the whole thing. Now, what's also important is Oracle RAC has network communications between all of the nodes, because it's a shared cache database system. So all of the communications between all of the cluster nodes is also going over the 10 gig network.
So that's that convergence of the storage network and the virtual machine network across the same physical links.
So to put this in perspective, when I'm doing a vMotion operation and say I'm moving this VM over here, I was using multi-NIC vMotion, so I'm using both of the 10 gig NICs for vMotion, and that will just saturate that as much as it can. The storage controller is also communicating with the other controllers across the network for the storage access. The Oracle databases are communicating across that same network to keep their cache and memory consistent. And I've got all of the users, or the user sessions, that are causing the load.
And they're all coming from this test machine over.
They're all coming from here. They're all coming over the same 10 gig network. So if you didn't have the features that Enterprise Plus from VMware provides,
network I/O control, crucial here,
then you could potentially run into problems. So I actually set the 10 gig NICs for vMotion to low priority for vMotion traffic, and high priority for Oracle RAC and the virtual machines. Now what I did is I did three different tests while I was monitoring the performance. We moved one Oracle node over. So we had 2 running on the same host, and I monitored the network utilization and the CPU utilization. So when these are running like this, we're getting close to 90% CPU utilization across the box. So very high load, up to about 1,000 transactions per second and about half a second in response time.
All right.
Under 200 users.
So looking fairly heavily loaded.
Pretty heavily loaded, yeah. And we're talking about a large database that's saturating, or 75% full on the actual enclosure. Then after a few minutes running on that system, I moved it back and monitoring the network utilization, CPUs, etc. And then the second test was basically this virtual machine moves to there, that virtual machine moves to here. So
concurrent to
two virtual machines moving exactly the same time to stress out the entire network, but also
be a fairly unusual situation to cause that.
Yes, in production sense, you wouldn't be doing this normally, because if you've got a database that's doing almost 100% utilization, you're probably going to pick a quieter time to move it.
Yes.
But this just proves that it works and there's no problems with it.
Most stress that you could possibly think of.
Absolutely. So that was the second test. Now the third test, which is what I call the merry-go-round test, I had the virtual machine on this host moving to here, the virtual machine on this host moving to here, and the virtual machine on that host moving to there.
So A goes to B, B goes to C, C goes to A.
Correct. All completely concurrent, saturating the network, but also running a 10 gig network at saturation point causes, it uses a core.
Collisions and...
Well, it uses a core of processing on the CPU, on the host as well. But all 3 of these moving at the same time, and they just worked. So the result was, I was using about 30 gigabits of bandwidth on each host during this period of time. It's quite a lot of bandwidth.
Out of 40
full duplex.
Theoretically possible.
Yeah, that was just, for most things, we had all the traffic, different types of traffic going over it, and the user sessions did not disconnect throughout this entire period. So even though I was hammering it under load this entire time, I didn't lose a single user session.
So throughout all of the tests, all of these vMotions, the users were sitting here on the test harness accessing their application.
Yep.
Did you see from the steady state of everything in one place to things moving around, how much difference in performance do the users see for that? Yeah,
so during the actual migration phase, it does reduce the performance slightly in terms of lower response times, higher response times and lower IOPS and things like that. And during the switchover period where it actually does the final bit between one host and another, then the response times do go up. But about a minute afterwards, they're straight back to normal again.
Right.
And it's a few orders of magnitude magnitude bigger in terms of response time. But it's only a handful of virtual users.
But that's also true for every vMotion that occurs. That's nothing specific to either Oracle or the platform we're on.
No, absolutely. So, and if you're a normal user, it's only a small percentage of the users would notice something.
Would have a transaction outstanding during that delay.
Yeah. And it's a couple of seconds delay during that is probably not going to be noticeable if you're going from an end user point to an application server back to the database server.
Yeah. It'll be one click on a web page took a little longer than you'd expect, but the next click is perfect.
Exactly. Yep. And again, you're probably not going to be running the system this high utilization because most production systems are run at a lower utilization level, in which case you probably wouldn't notice it at all.
Your average utilization much lower, and then you've given yourself more headroom for spikes, which of course is going to be critical for big applications.
I was really trying to simulate a worst case scenario that a customer could possibly get themselves into and still prove that the underlying infrastructure, the hypervisor, vSphere 5.5, the database, and the Nutanix storage platform still hums along. It works quite well.
Yeah, and you saw no problems in applications, no problems in access.
No, it just works, which is why we love it. Now, the great thing is I don't have to worry about managing any of the storage stuff. This is one data store, you plug and play. The thing that you do have to worry about setting up properly is the Oracle databases. So we can remove the complexity from the infrastructure. We can't remove the complexity from the operating system, the applications and things like that, but we don't add any extra to it. So you do the same things if you're a DBA as you always have.
So everything from the operating system upwards is still what it's always been for Oracle DBAs.
Absolutely. So multiple SCSI controllers, multiple disks. You have different disks for redo, for data files, for archive logs, etc.
Yeah.
All the database admins are used to that. We don't change it. The difference is you just don't have to worry about the underlying infrastructure because it just works.
It's the big easy button for infrastructure, as I think was the title of one of your blogs.
The big easy button for Oracle, well, that's right,
that's the one.
Absolutely. Now, I have a paper that's documenting these results that will be published on the Nutanix website. It's probably up there right now. So if you go to nutanix.com and search for the product white papers or tech notes section, you'll see my tech note, which documents this, but also the best practice guide, which has got all the gory details about how I set up the operating system, how I set up the virtual machines, the test results, and it also includes some just basic I/O subsystem benchmark metrics using SQL I/O.
Excellent, and that would be fairly similar pieces of information to what's on longwhiteclouds.com, your blog, talking about Oracle tuning for vSphere from many years ago by now.
Well, actually, no. It's a lot more than that because I've always held back a whole lot of the secret sauce that I've built up over the last decade of tuning,
as
Unix
you've been working as a consultant.
As I've been working as a consultant, that's right. But now I'm building in all the secret sauce to my documents and actually giving that to the customers so that they can go and, do it from day one.
There you go. You heard it here first. You don't need to hire Michael anymore. You can just read his white paper.
And I will be going into some detail on my blog at longwhiteclouds.com, and there's a lot of other information up there around business critical apps of all sorts of different types and just testing out the hypervisors, like what's the best SCSI controller to use and what difference does it make, that sort of thing.
And are you going to start looking at other platforms beyond vSphere? Because of course you're a vSphere guy in the background, but Nutanix is not a vSphere only solution.
No, that's right. So the good thing about Nutanix is you can run the same platform and you've got the choice about which hypervisors you use and which tool sets you use and things like that. So there are plans to do similar sorts of testing with Hyper-V, at least when it comes to Oracle. So Oracle's only one of the applications that I look after. SAP and enterprise Java systems and SQL Server and things like that as well. We want to give both the hypervisors a fair share. So most of the stuff I'll be doing is on vSphere, but we'll also be doing Hyper-V, especially when it comes to SAP, SQL Server, and Oracle.
Excellent.
KVM is also an option with OpenStack, but we don't see too many business critical apps being deployed on that at this time.
And you probably wouldn't see, well, not that there's any infrastructure tuning required on this Nutanix platform, but in cloud environments you just don't tune the infrastructure to the application.
Yeah. Well, we don't tune the infrastructure here either. We just tune the application, or you just set up the application to work properly.
Excellent. This is Notes4Engineers, some background information, some technical implementer information for people working in virtualization. If you'd like to find more Notes4Engineers, hit notes4engineers.com, 4 with a number, not the letters. And this has been Alistair Cook and Michael Webster. Thanks for joining us, and tune in for some more.